So this is about something that happened to us in a way, in that we've released a new product. We've released a new part of our monitoring, and it's a native container IDS module. So we drop it into the container pod, cluster, whatever you want to call it, right? And it monitors the containers themselves and the traffic, inter and intra-container traffic, which is what's important. Before that, we were on the host, and it was useful, but we couldn't quite see everything, and we didn't have some really critical metadata around the containers. Because if you're running containers, you can have all these IP conflicts between them, right? You don't really care about IPs anymore between your containers. So we deployed our new IDS into one of our first betas, and interestingly, found something almost straight away. So we released some content, and this is a bit of an overall timeline. Way back in February, we released some Monero mining content, and that's definitely, Monero is the one we're seeing the most of. And the reason for that is it's very easy to get started. You don't need to download the massive blockchain to get started. You can just get going. So during our investigations, we've seen some scanning, and certainly the Kubernetes kubelet sort of API interface is definitely the thing to notice here. There was a Medium blog that went out, and these guys, that was very interesting. I'll touch on that in a minute. But ultimately, almost immediately when we deployed our container IDS, we found these miners. And that was what was interesting. So what we're seeing basically was, as is everything, right, insecure configuration, old versions of software in place. And in this case, the default scenario was insecure if we really look at it closely. These guys, we'd sort of, at the same time, as is common in alert logic, we tend to be doing a lot of research, so we'll find stuff out around the same time that things get out into the community. And in this case, Alexander, his guys were hit as well by a similar thing to our customer that shall remain nameless, obviously. So ultimately, the kubelet's endpoint remained unauthenticated and open to the world by default, which is not a good place to be, right? So that earlier timeline was just a bit of a prep for this one, which is obviously more complicated, okay? So this is from the customer's platform point of view. So way back in December, they created some new Kubernetes nodes, and they were using them. At some point, somebody modified the security group, right? We've all been there. We've all seen this kind of thing happen, whether it's in the cloud or on-premise, and it was allowed for inbound access. They started up some new nodes. Within 28 minutes, someone had deployed miners onto them. It didn't take very long, because they're scanning for these open ports, right? They're looking for this stuff. 28 minutes is, well, it's a blink, really, isn't it, in the scope of the hack, the whole thing, right? There was no monitoring in place, so they didn't know about it. So it was costing them money and making someone else more money, to be honest. This went on for a little while. Obviously, they maintained the breach by not looking. A little bit later, we deployed our container IDS, or they deployed our container IDS beta into their environment at the same time as starting up another node. We immediately saw, within 4 hours, that node was breached. And after that 4 hours, 6 seconds later, we detected the incident and raised it back to them. So our SOC, the IDS, raised events into our back end. Those events were correlated into an incident. Our analysts looked at it, went, yes, this is definitely real, rang them up and said, hey, you've been breached, let's work this through. And that was, for us, from the point of I've started monitoring to I've been breached, a very short amount of time. But ultimately, in the scope of the average, it was also a short amount of time. But 26 days is quite a long time to have some miners in your environment without knowing about it, I think. So what did we find afterwards? We'd seen that scanning I mentioned earlier in the kubelet logs. We saw quite a bit of that, and we were able to obviously go back in and analyze that because we knew about the incident in the first place. Nodes 2 and 3, we found out they'd been breached previously using the logs again, and this is really an example that segues back into what I was talking about earlier with SIEM and things like that. Logs are fantastic, but logs are generally, in my experience, what probably happened a few minutes ago, maybe longer, right? And what's important for us is seeing what's happening now and monitoring the behavior of things at the time. So each node, and this is the important thing, right? This is how they could have protected themselves. What we see is repeated attempts to execute wget and curl, right? This is how they were exploiting it. The only reason they got breached is someone deployed a container with those on, which wasn't standard practice and shouldn't be standard practice. And this is the whole point, right? This is what we've been talking about in Linux, containers, and everything for decades. It's meant to be stripped back. But in infrastructure ops and in development, we tend not to do that, right? It's easier not to strip it back. It's easier to keep things in there so we can use them later. But this is a really good example of why you want your container to only be doing the thing it's meant to be doing and not have all these tools on it, right? Do your maintenance and management in a different way.